Use significant figures when performing calculations. All right, let's talk a little bit about significant figures before we get into this. Lots of words on this page, but I think it's important that we understand why we use significant figures. So, results that are calculated from a measurement are at least as uncertain as the measurement itself, right? So when we're measuring things, we're prone to make mistakes. Whether they're large or small, they're still going to be maybe off a little bit. So we need to consider uncertainty in measurements to avoid misrepresenting the uncertainty in calculated results. Okay, that's why we use significant figure to say, okay, we're going to accept and understand the uncertainty when we do the measurement. That takes care of then the results that come after it. Now, you might also be saying, well, what are significant figures? Significant figures are digits in a number that are reliable and necessary to indicate the quantity of something. Because again, remember, we are measuring something. Now, significant figures are all non-zero numbers. Zeros that are between two non-zero numbers. So if I had like 304, that zero is significant because it's between two non-zero numbers. Leading zeros are not significant. So like 0.04, the only significant figure here is the 4 because these are leading zeros and therefore not significant. Okay, rules to determine significant figures. When you are adding and subtracting, we will round to the same number of decimal places as the number with the least number of decimal places. When multiplying and dividing, we will round to the same number of digits as the number with the least number of significant figures. So you'll notice when you add and subtract, it's about decimal places. When you multiply and divide, it's about significant figures. And we're rounding, so we're going to use our normal rounding rules. First, let's just round. So we're going to round the following to 3 significant figures. So in letter A here, 539. Those are 3 significant figures. So I'm going to look at the 2. 2 tells me to round down, so this would be 0.0539, rounded to 3 significant figures, right? So rounding rules are in effect because 2 is less than 5, I round down. So the key is to first identify your 3 significant figures. In B, 217 are my 3 significant figures. Again, I have a 2, so that tells me to round down, 21.7. Again, 3 significant figures for letter C, 1, 2, 3. 8 tells me to round up, so I'll have 3.59. So that's just rounding to significant figures. Let's do a few rounding that are different numbers. Okay, so 4 significant figures for letter A. Well, these are leading zeros, so they're not significant. 1, 2, 3, 4. Again, this 0 is between non-zero numbers, so it is significant. 2 tells me to round down. So I have 3, 0, 4, 6. To 4 significant figures. When you're rounding to 4, you should have 4 significant in your answer. Okay, and then in the last one, 2 significant figures. 2, 4. This 9 tells me to round up. So to 2 significant figures, my answer would just be 25. Okay, now let's do some operations. We're going to add. Now, remember that when you add and subtract, it tells you the least number of decimal places. So this one has 4 decimal places. This has 3. So my answer will have 3 decimal places. Okay, so now when you add these 2 together, you get 1.7957. So to 3 decimal places, 7 tells me to round up. So I end up with 1.796 grams. Don't forget your label. Same rule for subtraction. I have 0 decimal places here and 1 decimal place here, so we will round to 0 decimal places, which is basically a whole number. When you subtract, you get 44.8 rounded to the nearest whole number. 8 tells me to round up, and I'm at 45 centimeters. Okay, let's multiply and divide. When we multiply and divide, we go to the least number of significant figures. So this number has 4 significant figures. This has 2 significant figures. So we will round to 2 significant figures. Okay, so 2 significant figures for our answer. When I multiply these together, I get 1.16439. 2 significant figures is 1, 2. I look at the 6. 6 tells me to round up. So 1.2 centimeters squared is my answer. Because when I multiply, centimeter times centimeter is centimeter squared. And the last one, I'm dividing. Same thing about significant figures. This has 5 significant figures. This has 3. So my final answer will have 3 significant figures. When I divide 374.86 by 96.3, I get 3.892627 dot dot. It keeps going and going and going. So 3 significant figures. 2 tells me to round down, so my answer is 3.89 grams per milliliter, because we're dividing, right? 374.86 grams over 96.3 milliliters. That's why I have grams over milliliters. And that is playing with significant figures.